Hello and welcome back to the channel Understanding Concepts of Physics. So we are back with the same topic, thermodynamics, and today we are going to discuss with a very small topic, and that is assumptions of thermodynamic processes. So let's see how to do this topic. Now, if you can see, there are four assumptions. Let's do one by one. Assumptions of thermodynamic process. The first is all processes are reversible and they are quasi-static except adiabatic process. Now, to say it's a very single line statement, but let's try to understand. Now, there is something called as a reversible process, a process which can repeat, which can regain to its original initial and final states along the same path is what is called as a reversible process. Now more on these kinds of processes in the coming videos, as we need to discuss each and every kind of process in pretty detail. So all these names, reversible, quasi-static, adiabatic, all these are processes which we are going to discuss in the coming lectures. But because we are starting with the thermodynamic process, we should initially understand what assumptions are. So in the first assumptions, we are assuming that all processes should be reversible processes. That means it should regain its initial state along the same path. Next is quasi-static. Quasi-static means very slow. So a process which occurs very slowly is what is called as a quasi-static process. And adiabatic process means a process in which heat is kept constant. So if the heat is kept constant, that process is called as an adiabatic process. Even fast free expansions are also classified under adiabatic process. So all processes are reversible and quasi-static. That means they are reversible and they are pretty slowly, but we are assuming that only except the adiabatic process. So adiabatic process is fast free expansions. Then the second assumption states that the system is an ideal gas fitted with movable frictionless piston, frictionless and massless. So we are going to assume that whenever we are considering a gas is in a container in which there is a piston, and this gas is inside the container, and this piston is movable, so it can move up and down. It is massless and it is also frictionless, so there is no friction at the corners of the piston. So in order to understand thermodynamic process, the system is an ideal gas fitted with a movable, frictionless. Movable, it can move. Frictionless, there is no friction in the piston, and the piston is having negligibly small mass, so we can ignore that part. So this is what is the second assumption. So in order to understand thermodynamic process, we need to accept these assumptions. Then third is what is called as the walls of the containers may be conducting or insulating depending upon whether the process is isothermal or adiabatic. Now again, I would say just wait for a few videos more. Come back again on these videos, because we are going to discuss isothermal and adiabatic process in much detail. So the walls of the containers may be conducting. That means it can transfer heat when we are in isothermal process. So I may have a piston in a container in which the walls are conducting walls, so the heat may flow in and out. Okay, it may go in, it may go out, like this. And isothermal process is a process in which the temperature is kept constant. So isothermal process is a process in which the temperature is kept constant. So the walls of the container may be conducting for isothermal processes. However, it should be insulating for adiabatic process. So I may have a piston or a system which is insulating to the surroundings. So this, let's say if this is an insulation, So heat is neither going to flow out, heat is neither going to go in. This means the system is insulated, and if it is insulated, the heat energy is kept constant. So in an adiabatic process, heat is kept constant, and in a isothermal process, temperature is kept constant. So the walls of the container is conducting in isothermal process and insulating in adiabatic process. This is the assumption. And lastly, ideal gas equation is applicable, which we have studied. PV is equal to nRT. P stands for pressure, volume, temperature, universal gas constant, and N is number of moles. So we are going to assume that whenever we are studying about thermodynamic process, we are going to assume that these four assumptions are valid at this point. Only then we will be able to understand thermodynamic process in a bit detail. So we are winding up today in a very short video. Thank you so much for watching. In case if you have followed, subscribe the channel in case you have done, if in case you have not done so, and keep following the videos. Isolated videos if you watch, probably you won't be able to understand. I would suggest that keep a link, keep use a playlist in order to understand all the videos. Thank you so much. Bye.